A quadratic equation, and thus a quadratic characteristic equation, can have two real roots, two complex roots, or one real root. We've considered the first two cases. We now consider the third. Suppose we're looking at a differential equation, ay double prime plus by prime plus cy equals 0. Now suppose that the characteristic equation, ax squared plus bx plus c equals 0, has only one real root. That is, suppose we can write it as a times x minus r squared equals 0. We get a solution from this. E to the RT. But for a general solution, we need two linearly independent solutions. What's our second solution? We won't go into detail, but we'll indicate generally where the answer comes from. If we have this solution, e to the RT, then the superposition principle says that C e to the RT is a solution for any constant C. This isn't useful because these solutions aren't linearly independent. But it gives us an idea of what to try. This is a constant function times this solution. Maybe there's a non-constant function we could use. Let's try y sub 2 equals u of t times e to the RT. Well, if we plug this into this equation, we get a times u e to the RT double prime plus b u e to the RT prime plus c u e to the RT equals 0. Well, this is not going to be lovely, and we omit the details. Taking the first derivative here requires the product rule. Taking the second derivative here will be even worse. However, if we force our way through the calculus, we get an extremely simple equation. U double prime equals 0. Can we find a function whose second derivative is 0? We certainly can. U of t equals b1 plus b2t, a linear function. Now, y1 equals e to the rt, and y2 equals b1 plus b2t e to the rt are linearly independent. They are multiples of each other, but not constant multiples. And we can form the general solution. Y equals d sub 1 e to the rt plus d sub 2 b sub 1 plus b sub 2 t e to the rt. Rearranging these terms a bit, y equals d1 plus d2 b1 e to the rt plus d2 b2t e to the rt. Now, this is a lot of constants, but we can consolidate them. And get y equals c1 e to the rt plus c2t e to the rt. And there's our general solution if we have only one real root. We have now seen all three cases that the characteristic equation may fall into. Shortly, we will see that this material generalizes to higher order linear differential equations.